Welcome to this video on measures of center. What are measures of center? As the name implies, measures of center tell us where the middle of a set of data is located. There are multiple ways to find the center of a set of data. The methods we will explore in this video are mean and median. In this video, you will learn how to compute the mean and median of a set of data, and you will also learn what the mean and median tell you about the distribution of data. Let's start by learning how to calculate the mean or average of a set of data. The mean or average of a set of data is found by summing the data values and then dividing by n, the number of data values. Suppose you want to find your average test rate in a given course. Your 5 test scores are 79, 85, 64, 100, and 95. What is your test average? In order to compute this, we need to first sum all 5 test scores and then divide by n the number of data values. Notice in this equation the division symbol is also acting as a grouping symbol. This tells us that we have to add all 5 test scores before dividing by 5. When we add up all 5 test scores, we have a sum of 423. Dividing 423 by 5, we find an average of 84.6. This means that your average test score in this example is 84.6. The mean is a non-resistant measure of center. Let's explore what that means. The mean is heavily affected by the presence of one or more extreme data values or outliers. An outlier or extreme data value is a data value that lies far away from the rest of the set of data. In other videos, you may learn a concrete way to calculate whether or not a data value is an outlier. But for now, we are just going to accept the fact that it lies far away from everything else. Let's go back to our test example to demonstrate this. Suppose you have one final test in your class, but you are sick that day and earn a 0 on that test. Notice that this new grade of 0 can be considered an outlier because it is much lower than any of your other test scores. So our previous test average, as you can see, was 84.6. What happens to our new test average or mean when we add in this 6th score? Now we are adding not 5 but 6 data values, and notice that the 6th data value is 0. So when we sum those test scores, we have the same sum, which is 423. Notice now that we're not dividing by 5 anymore, but we're dividing by 6 because there are 6 different test scores. Our new test average then is 423 divided by 6, which is 70.5. So let's compare the previous and the new test average and see how they have changed. We started out with a strong, solid B average, 84.6, but since we missed one test and we had a 0 there, all of a sudden the test score dropped from a mid B to a low C, just because of one exam. This is an example of how the mean is very sensitive to the presence of extreme data values. To describe this characteristic of a mean, we say that the mean is a non-resistant measure of center. This is another way of saying that the mean is heavily affected by the presence of outliers. We can also think about the mean as the balance point of data. Here is a picture of 5 test scores. Notice that the fulcrum or balance point is located at the mean 84.6. If you imagine this as a seesaw, what would happen to the seesaw when we add that 6th data score? Notice how this outlier makes the seesaw unbalanced. That means 84.6 is no longer the center or the mean of the data. To rebalance our seesaw, we have to move the fulcrum, or the center, of our data. The new center of the data is 70.5. Now let's explore how to calculate the median of a set of data. The median of a set of data is the middle number. To find the median, you first have to order your data set from smallest to largest, or from least to greatest. Then you can find the middle of your data set. If there are two numbers in the middle of the data set, then you have to find the mean of these two values. That will be your median. Let's start by using an example with an odd number of data points. Going back to our first example, we had 5 different test scores: 79, 85, 64, 100, and 95. The first thing we have to do is to put these in order from least to greatest. Doing so, we have scores of 64, 79, 85, 95, and 100. Now we can find the middle data point in one of two ways. The first method involves crossing out values until you find the middle value. So we start with the lowest and cross that out. Then we go to the other end and we cross out the highest number. Working our way in towards the middle, we find that the middle number here is 85. Therefore, 85 is the median of our data set. A second method we can use is to use the formula n plus 1 quantity over 2, where n is the number of data points. In this case, as we said before, n is 5 because we have 5 data points. Therefore, our formula becomes 5 plus 1 over 2, or 6 over 2, or 3. This means that the third data point is the median. So we can simply look at our set of data, find the third data point, and know that this is our median. Let's repeat this process if we have an even number of data points. So let's go back to our average example with 6 test scores. So if we have 6 test scores, they are 79, 85, 64, 100, 95, and 0. Remember, before we can find the median or middle number, we first have to order them from smallest to largest, or from least to greatest. Doing so, we have 0, 64, 79, 85, 95, and 100. Now we can find the middle data point in one of two ways. As before, we can cross out values until we reach the middle. So we cross out 0 and 100, 64 and 95, and we reach the center and realize that there are two values in the middle, 79 and 85. We have to find the mean or average of these two numbers. We do this by summing them and dividing by 2. This tells us that the median is 82. We can also use the other method we mentioned, which is to use the formula n plus 1 over 2, where n is the number of data points. In this case, we have 6 data points, so n equals 6. 6 plus 1 is 7. 7 over 2 is 3.5. This means the median lies halfway between our third and fourth data point. Our third data point is 79. Our fourth data point is 85. Halfway between this, or finding the arithmetic mean of these two numbers, we find is 82. So again, using the second method, we find the new median is 82. Let's discuss this idea of resistant versus non-resistant measures of center. Let's look at how both the median and the mean change in the presence of an extreme value or outlier. First, notice how much the presence of one outlier affected the mean. The mean decreased by 14.1 points. Again, it started as 84.6 and it dropped to 70.5. Compare that to how much the median changed. The median changed by only 3 points. It started at 85 and it only dropped down to 82. From this, we can see that the mean is a non-resistant measure of center. It changes drastically in the presence of one or more outliers. Conversely, we see that the median is a resistant measure of center. It does not change significantly in the presence of one or more outliers. Another thing we can learn is that in the absence of an outlier, the mean and the median were almost the same. When the mean and median are the same or very close to the same, this tells us that our data is not skewed. And if you look at this picture, this graph down here, you can actually see what would be described as a uniform distribution. It is clearly not skewed left or right. Now, when we add this outlier, this extreme value over here, all of a sudden, our data set is not uniform anymore. In fact, it's skewed left. Notice that when we look at the mean and the median, before they were almost the same. Now the mean is 70.5 compared to a median of 82. The mean is now much lower than the median. In general, the mean follows the skew of the data. If the mean is less than the median, this will suggest that the data is skewed left. Conversely, if the mean is greater than the median, this suggests that the data is skewed right.